Now let's first talk about SwiftUI state management changes. Before iOS 17, in order to maintain SwiftUI state, we have a number of options. We can use add state, we can use state object, we can use observed object, we can use environment, and we can use binding. Now what Apple is suggesting that for iOS 17 and above, they're trying to simplify state management. As you can see, before iOS 17, you have 5 or even 6 different ways, if you count the environment with the keys, to manage the state. And that's just too much, and it causes too much confusion. So for iOS 17 and probably above, Apple is saying that you should use state, environment, and bindable, which is a new property wrapper that they have introduced. Let's go ahead and take a look at the documentation of at least the state, environment, and bindable. Now, if you look at the documentation of environment, make sure that you are actually selecting the diff tag over here and not only selecting this one. So we'll select any one of them is actually fine. I mean, you can select any one of those and we'll be able to see what new things are added. So if you scroll down, you can see that Apple has added some brand new initializers. So right over here. So this means that when you are using the environment property wrapper, you can provide a particular value that you want to put in there. Environment, it kind of becomes environment object. So environment object is no longer needed when the environment can actually do the job. And this property wrapper with the initialization with the value type is going to allow you to simply say that, okay, my type is app and app is an observation. So you can actually put that in the environment just like you put an observable object in the environment object. So there's no need from iOS 17 and above to start using environment object. You can do all the things that environment object was doing using the environment, using this initializer. If you go to the state is actually quite the same. The only new thing that they have added to the state is this one new initializer in which you can pass in a wrapped value. So that's pretty much it. Apart from that, it functions as the exactly same thing. Now, one of the new property wrappers that we added in iOS 17 is the bindable. The bindable property wrapper, the main function for this property wrapper is that if you are trying to change the parent from the child. So as you can see in the documentation, it says a property wrapper type that's supposed to create binding to the mutable properties of observable objects. So if you have the observable object and you pass that to the child, then that child can change that, and then that change is going to be reflected in the parent. So it works kind of like at binding. We are going to take a look at all of these property wrappers in the upcoming lectures, but at least now you have an idea of where the SwiftUI is actually moving. Instead of having 5 or 6 different ways for state management, now we have state, we have bindable, and we have environment. So let's go ahead and first start by learning about state. State is used for local private data for the view. This means that if I create a state variable to hold some data, that will be only for the content view. That's why it's known as the private state or the local state. It should not be exposed outside of the current view. Creating the state is actually pretty simple. Let's go ahead and first start with creating a counter. And you will notice that if you have been working with SwiftUI, the state didn't really change that much. It's exactly the same. For counter, I'm going to go ahead and create a private, and it's always a good idea to create state private so it is not accessible outside of the content view. And I'll create a variable called count, which will be integer. So what we are trying to do is we're trying to gather the data, we're trying to create a count that can go up value, meaning from 0 to 1, 1 to 2, 2 to 3. And one of the great things about setting the state value is whenever the count changes, the body gets re-evaluated again. So right now in the body, you can see we don't really have anything that can update the count, but I can go ahead and create a button and I can say increment. And in the increment, I can go ahead and also say increase the count. So this means that whenever I will press the button, it will increment the count. But one thing to notice over here is that even though we are incrementing the count on line number 17, in the body of the view, nobody is using the count to be displayed on the screen. So even though the count will be incremented, that's fine, but nobody is using it. And if nobody is using it, the body will not really get reevaluated. Nobody cares. I mean, we don't really need to reevaluate the body to see something has changed because we're not even using the count. Well, we can change that by adding a text view over here and then displaying the count. We can also change the size of the text font to be large. Now you can see that on line number 18 and all that, we are actually changing the count. We're incrementing the count. And on line number 16, we're using the text view to display the count. And that's the important part, displaying the count. We are using the count. We're simply not updating the count and discarding it. Nobody cares about it. We are updating the count and we are using the count. We are displaying the count. And SwiftUI is very smart. When it sees over here that you are incrementing the count and you're also using the count, then the body gets reevaluated. And then during the reevaluation, SwiftUI is going to find out, oh yeah, you are actually changing this count. So I am going to go ahead and re-render it. And keep in mind that in SwiftUI for iOS 17, they have changed it and they have also increased the performance. So now the body only gets reevaluated when something needs to be changed. So it's not going to get reevaluated willy-nilly and then try to make a diff and then find out which change. It will only get reevaluated when something has changed. So that is definitely going to increase performance. Let's go ahead and see what happens if I increment the count. Well, as expected, the count will be incremented and displayed on the screen. Every time I increment the value of the count, the body gets reevaluated and the text gets re-rendered because that is the one that is creating the count. There are a lot of different controls that you can use that are using the binding for the state variable. Now, apart from the text field variables, we can also have a toggle variable or a toggle control. Toggle control can switch between the on and off cases. So if I want to create some sort of a toggle view, I can use toggle. You can see that in the toggle, we can have many different initializers over here, but the one that I'm going to use is the one that takes in the binding. So this is where you can actually pass in the state variable. So I'm going to use the toggle. Now currently I don't really have this kind of a binding for state, but I can create it, not a big deal. State private var is on, which is a boolean, and initialize it with false. Now I can go ahead and pass in the binding. But if you pass the binding just like this, it's not going to work because this is just a boolean variable. In order to pass the binding, you have to use the $sign. $sign means that this is a binding. This means that whenever the toggle control is going to change the value of or switch from on to off, the variable over here on line number 13, our binding state variable, gets updated. For the label for our toggle, we can create some sort of a toggle over here. Let's say light switch or light. Light is on or light is off. All right, but we should probably pass it in another view like this. Great. Now I can go ahead and turn this on, turn this off, on, off. One of the things we can also do is we can change the button over here to say on and off. And the good thing is that we can simply change it over here. We can say if it is on, then the button will say on, else it will say off. Now you can see the button is actually saying off. If I turn it on, it says on, and then off, on, off. Great. One thing to note about over here is that the button is simply using the isOn binding, which is a state variable, to reflect that whether it will return on string variable or off. But the button itself is not changing the value of isOn. There is a way that the button itself can also change the variable, especially when these buttons are inside some sort of a child view. Sometime you will have a child view that needs to change the property or the value on the parent view. And in those cases, we will have to look into something called bindable. Bindable is introduced by Apple as a new property wrapper, and we will be using bindable a little bit later on. So let's go to the next lecture and learn about bindable. Now let's go ahead and talk about bindable property wrapper. You will use bindable when your child needs to update the parent or talk to the parent. So let's go ahead and take a look at a simple example. Let's say that apart from the content view, we also have another view called room. And room is a simple view. So let's go ahead and create room. So I'll say body, some view. And what the room view actually does is room view has a toggle to turn on and off the light. So I can create a toggle and I can say is on, and then I can pass some sort of a light over here. So I can create a state variable inside the room. We can call it light, and it can be a Boolean variable, initial value false, and I can simply pass it is light over here. And I don't really want anything else to be displayed, so I'm just going to pass the empty view dot fixed size so that we only see the toggle. Now if I want to use this room view, I can simply go ahead and use the room. And you can see that the room appears with a toggle. I can go ahead and switch the toggle, but one of the problems is even though by toggling it, the light value is changing, is toggling between true and false and true, our main view, the content view, is not getting those values. So the content view is saying that whenever you turn on the light, you let me know, because then I have to, make the color of the background of the whole content view to be yellow and white depending, or yellow and dark, or yellow and black, depending on if the light is turned on or off. In other words, the room, which is a subview, a child view of the content view, needs to send some information back to the content view. But how is that possible? Well, when you were using anything less than iOS 17, you would use the binding. And it is still available. It's not really marked for deprecation yet. But now Apple is suggesting that you should be using bindable. So let's go ahead and see how we can use bindable. In order for the bindable to work, the first thing we need to do is we need to import SwiftData. And the reason we're importing SwiftData is because in the SwiftData module or the framework, we have the observable macro. If I don't import SwiftData and try to create some sort of a class called light with a single property called isOn, and we can make this Boolean false. And if I try to build this right now, you will see that it builds successfully. But if I want to decorate it with observable macro, then it's going to complain because it's saying that, hey, I don't know where this observable macro coming from. So let's go ahead and uncomment SwiftData. And now it works correctly. So this means that you do need to import SwiftData. Another thing to note over here is that for the light, I'm making it as a class. What about if I can make it as a struct? So it definitely does build successfully, but you will see later on that when we use a struct, it is going to give us a little bit of a problem. Let's make it a struct for now. And now inside the room, we are going to start using our light, but we're going to use the new bindable property wrapper. The bindable property wrapper can only be used with the types that are conforming to observable, which you can see that my type, the light that I created, is actually conforming to that. So let's go ahead and use bindable light. There we go. Automatically you can see that the build actually failed. And now it's telling you that cannot convert light to argument something else and conform to observable. So there is something wrong with this. Let's go ahead and change the light to a class. Now, if we change the light to class, then it kind of removes that particular error. That's fine. But we still have errors over here. So let's go ahead and fix this error, because light is now a class and we are not trying to bind it to a class, but one of the properties of the class. So we're going to use isOn. Also, the room no longer takes nothing. You have to pass something over here. So I'm going to go ahead and say for the room, I need to pass in the light. But where do I get the light? Well, this is where you can use the state variables to construct light inside the content view and pass that light over here. Now again, if I go to my light class, which is marked with observable macro, and I change it to struct, again, we have all these issues. So we have to use class, not a struct. Now what we want to do is we're already passing the light, which is state. This light gets to the room as a bindable wrapper using the bindable property wrapper. And now we are changing one of the properties of the light instance is on. We're toggling it between on and off. Whenever the value of light changes from on and off, that is going to tell the content view that something has changed and you should go ahead and refresh or re-render. So in those cases, it is up to us that what do we want to do? And what we want to do in our application, we just want to make sure that we are changing the color of the content view based on the light. So you can see over here that we are setting the frame to maximum infinity, so it's going to take up the whole screen. And we're changing the background color based on the value of the light. If the light is on, we're going to change it to yellow, or else it will be black. Let's go ahead and run the application and see how it works. Right now, the light.isOn is going to return you false. When it returns false, it's going to take the black color, and that is why you can see the black color. If I mark this, or if I change this switch from off to on, now you can see that the light color has actually changed, and the actual room is going to tell the content view that, hey, I've changed the light, so go ahead and reevaluate yourself. And when it does reevaluate, it says, oh yeah, light is now on, so I'm going to mark this with yellow. So now the color is changed to yellow. And I can toggle between these two. So the main reason that we are using the bindable is so that our child control, or the child view, which in this case is room, can talk to the parent, can send the values to the parent. And by using our bindable as a light, which is marked with observable, we can directly bind to the properties. So that is one of the great features of using bindable. Thank you so much. All right, so now let's go ahead and take a look at the changes in the environment. The environment object, which was introduced in Swift when the Swift was announced, the main purpose for environment object is to provide some sort of a global state. So if you have deeply nested views, instead of passing down the values to those views, you can simply grab it from the environment object. Well, now the environment object, you can simply use environment. So environment object, like environment object, is now replaced by environment. And when I say replace, I'm not saying that environment object is deprecated, at least it's not deprecated for now, but now you can use at environment. So let's go ahead and see how we can do that. Currently, you can see that we have our content view, and we are creating kind of like a local state, passing it to the room as a bindable. And whenever this room toggles the state, it tells the content view that, hey, something has changed, so you should also re-render yourself. And the effect is that this particular toggle is inside the room view. Whenever we toggle, we can actually send the signal to the content view, and the content view can re-render itself by changing its color. Great. What about if I had a different view? What about if I had another view? Let's say we can say a cabin, which is a simple view. It will also have a body. And what I want to do is in the cabin view, I also want to change the view itself. So for the cabin view, let's say that we are displaying a light bulb. Okay. And we can use our cabin view by simply saying cabin. There we go. We can even change the size of the image by saying large title or providing a different font. Okay. Even this hierarchy is not really deep enough. I mean, we have the content view and now it has two children. But cabin view can itself have some other views, or even the room can have some other child views. And if we wanted to pass this light to all of them, then it's going to take a while because we have to pass it as a dependency to our views. So now if the cabin view needs the light, then we will have to pass it down using over here as a constructor or initializer. So what the environment does is that the environment allows you to handle the global state. Now keep in mind that the environment, however it is working in SwiftUI, is a little bit weird and a little bit different than the environment object, and you will see in a moment. The first thing I need to do is to inject the global state or environment at the very root level of my application. Keep in mind that it's not always that you need to inject the environment at the root level, but for this example, I do want my environment to be available throughout my application. So since I'm using previews and the root level for me is the content view, I will inject the environment right over here in the content view. You can see that you also have the environment object which was used in SwiftUI, and now they're saying that we should start using the environment. And one of the initializer of the environment, as you can see, you can now pass in something that is observable, which is great because we already have something that is observable, which is our light view. Keep in mind that whatever we're doing over here is only for the preview. When your application is actually running, it is going to look at the app file, and over here we're not really passing anything in the environment. So make sure that you do that also. Great. You can pass in more environment variables if you want to. That's perfectly fine. It simply means that you're creating the slices of the global state. Just make sure that whatever you're passing, which we're passing light, is actually conforming to observable. Great. Now, how do we use it? Well, inside the content view, we can use the environment by simply switching the state over here and saying environment. We also need to specify a type, that what kind of object this is. So I'm going to say light type. Light because this is the object that we put inside there. We don't really need to do any initialization part. It is injected, so we will be able to get this object out of the environment. The next thing that we want to do is we don't really want to pass anything to the room now. If the room needs something, it can simply get it from the environment. So let's remove this constructor or initializer dependencies. Let's go to the room. The room is currently depending on the bindable. we will also go ahead and remove that, and we'll say that, hey, room, if you need something, why don't you just go ahead and get it from the environment? So we'll also get that stuff from the environment. Now, one of the problems in this approach, at least which is different from the environment object, is that when we try to conform overhead, when we try to bind the isOn property on the environment, it kind of complains, which is kind of weird because I didn't expect it to complain. So what it is saying is that, hey, you can't really do that. If you want to do binding, you should create a separate view, which is kind of annoying because now I have to go and create a separate view only to contain this. Why can't the room just contain the toggle? But I guess the Apple currently is saying that, well, the room is going to serve as a container, and you should use subviews to perform any kind of bindings because you do have to use @bindable. So let's go ahead and create a separate view for our light. I'll go ahead and create a light view, which is a view. And this is where I will pass in the bindable. Now, keep in mind that all of these things can actually change in the future versions of SwiftUI. Now, for the body, since it is bindable, well, we can bind. There we go. So now, instead of using the toggle over here, we can simply go ahead and start using our light view. In the light view, we do need to pass in the light, so we can simply pass in the light. And now it builds successfully. If I run the application right now, you will see that I can change this and our application works as expected. This means that every single time I change the toggle is going to change the binding, which is basically saying that you're changing the environment variable because that is exactly what you're passing. And once it changes, the content view says that, okay, you changed the environment, I'm going to go ahead and re-render myself. We can also apply the same thing with the cabin. So if the cabin needs to access the environment, we can simply go ahead and access the environment using the environment property wrapper. And now we can actually change over here. We can say if the light is on, then go ahead and use lightbulb.fill, else simply use lightbulb. Keep in mind that in this case, we didn't really have to create any subview because the cabin view is not really changing the value of the environment. It's simply using the value to display either the light bulb fill or simply the light bulb. So now when I change the environment, you can also see that the light bulb is switching between the light bulb.fill and light bulb, which is not filled. So this is how you can use the new environment. One thing to keep in mind again is all of these things can actually change. The way that the observable is working, the way that you have to now create a subview in order to change the binding, all of these things can change in the future. So if it changes in the future, I will update these videos and you will be making sure that you are getting updated information. Thank you so much. Hey everyone, if you're liking this video and want to support my channel, then check out my brand new course, SwiftData, Declarative Data Persistence for SwiftUI. Now this course is still under construction, but you can watch around 2 or 2.5 hours of videos, and I keep on updating as I learn more about SwiftData framework. So you can see that you can already start learning about how to persist information through the use of SwiftData. You can learn about Swift one-to-many relationship, many-to-many relationship, and so much more. So this is a great course. This is the only course that is available on Udemy right now. There's a link right there in your YouTube description. Check out the link and make use of this course. So go ahead, try this course out. This is still in construction, so this course is still being developed, but you can watch it as it is being developed. So thank you so much for your continuous support.